In today's video, we're going to look at a method for measuring the speed of sound using the wave equation. I have a signal generator. It's set to 6,000 Hertz at the moment and connected to a speaker and a double beam oscilloscope. I've also got connected to the oscilloscope an amplified microphone, and you can see it's picking up my voice quite clearly. If I turn on the steady sine wave signal from the signal generator, you can see that it's picking up a nice trace, and you can see which one is the microphone because it's also picking up my voice still. If you wanted to move where the peaks are, you can adjust the trigger level to get them on the peak on a line. And at the moment, the peaks are just about lined up. But if we move the microphone, you can see the peaks go in and out of phase. So when they are in phase, that will be a wavelength, or wavelength from that in phase bit, the next in phase bit. So if we start down here at 0.2 meters, we can take a measurement to the next one, but it would be more accurate to 2, 3, 4, say 5 wavelengths. And 5 wavelengths is very close to 0.3 of a meter. So if I do the calculation, so it's 0.3 divided by 5 will give us the wavelength, and multiply that by the frequency, which on our signal generator it's showing 6,000 Hertz, gives us 360 meters per second for the speed of sound. We can change the frequency, and you can see the microphone one changed because the wavelength is changing. Lower frequency is going to be a longer wavelength. So doing a longer wavelength, lower frequency might give you a more accurate result. And it's worth doing this in class to show that there are different ways of getting the same answer. Now the ruler is blue tacked down because that's a reference point that needs to be held in place. Using the amplified output of the signal generator, so I've got the channel 1 from the signal generator on 2 volts per division. That's vertical. Time base on 20 microseconds, and the amplified speaker is on amplified microphone is on 0.1 volt per division. You could do this with the normal crystal microphones. They tend to pick up a little bit of mains hum, so I've gone for the amplified one.